So I'm Tyler Hogenkamp. I was interning at Ducommun Aerostructures, and I'm a junior now, but I was a sophomore at the time that I was interning at Ducommun. So a little bit about Ducommun. They're headquartered in California and was founded in California in 1849, and they produce aerospace products for military and commercial applications. And some notable suppliers that they have is Boeing, Textron, and Airbus. So they have two specializations in the aerospace industry. They have an electrical based system where they mostly work on like circuitry and stuff. And they have another one that's structural, where they do the structural airframes and all sorts of that for aerostructure, like it's aerostructures. So for the Parsons location, they do the structural components, which mostly deals in titanium and aluminum. And the Parsons location hosts the largest superplastic forming hot press, or the SPF hot press. And some of the projects that Ducommun, specifically at the Parsons location, wanted me to look at was general waste reduction and reduction of hazardous air pollution, pollutants, or volatile organic compounds, VOCs. So my project summary, all of them were recommended except for the water jet closed loop cooling system, and include the masking, chemical line 1 neutralizer, pH neutralizer, hot form / vacuum press blankets, and the press 12 closed loop cooling system, as well as water jet closed loop cooling system and abrasive recycling. And actually, the press 12 closed loop cooling system was implemented during my time at Ducommun. So my first project was the masking project, and currently they use maskins as like a barrier between the chemicals and the part when they are dipped in the chemical mill, and they put holes in the masking where they want the chemical milling to actually happen. So their application of this masking accounts for roughly 65% of toluene emissions and 62 overall emissions of the plant, which was done by a previous intern. The calculations for that was done by a previous intern. And this causes Ducommun to require a Title V air permit, which comes with the EHS manager and regional manager have to do emissions training and do regular emissions testing around the plant, which the training costs in total about $1,000 per year, and about a day of training and several hours of doing emissions testing each year. So an alternative that Ducommun has been looking for, they finally found one that is water-based, so it will release no VOCs or HAPs. And I was in charge of doing the testing to ensure that the masking would protect the part properly. And got to about the final testing stage. Just need to do another batch test. I don't know if that's been done yet, but it should be good after the batch test. But once it's implemented, it will reduce VOC and HAP emissions by about 9,000 pounds per year each. And this reduction results in a Title V turning into a Title II, which will not require the emissions training. And something that I forgot to mention was the Title V also puts Ducommun under more scrutiny. So they have more audits due to this Title V, and with the more audits, potential for fines or even the revocation of their permit, which it was hard to determine the possible cost of that. So it wasn't calculated, but reducing the Title II would reduce the number of audits and stuff like that. So my next project was chemical line 1 projects. Ducommun has 2 chemical lines, 1 and 2, and the second one has a pH neutralizer system for neutralizing the chemical tanks as well as the rinse tanks. So that way there's no hazardous waste produced through this process. But however, chemical line 1 only has a system that neutralizes the pH for the rinse tanks, which leaves the chemical baths needing to be disposed of as hazardous waste. From looking at the disposal history from last year, I found that it costs an average of $124,000 per year to dispose of this chemical bath content. And it accounts for 108 tons of hazardous waste per year. So an alternative to the current situation is implementing a system that's similar to chemical line 2's, where it balances the pH of both the rinse and chemical baths. Also, so it's hard to determine what a new system would perform like. So like how much water it would use or energy and stuff like that. So I decided to compare it to chemical line 2's current system because I figured it would probably use the same amount of water. And from talking to the maintenance manager at Ducommun, he told me that the second line or chemical line 1 or chemical line 2's system uses about double the amount of water chemical line 2's. And from the outfall data of chemical line 1's, I found that chemical line 1 uses about 2.7 million gallons annually, doubling the amount of water that chemical line 1 would use. They would use 2.7 million more gallons annually, which accounts for a cost of $42,000 per year and a net annual savings of $83,000 per year, and reduce the hazardous waste production of 108 tons per year. From emailing a company, GOAD, a new system was quoted to cost $120,000, and this makes the payback period about 1.5 years. So the next project was vacuum press project, and Ducommun utilizes insulating blankets for the vacuum presses. And their vacuum presses, basically, they have a die, then they put a part onto the die, and then vacuum seal it down to form the vacuum press and heat it up so that it keeps warm. So these insulating blankets is to keep the temperature high for the part. And under pressure, they deteriorate very fast and become crumbly and even make holes in the blankets. And sometimes the insulation gets into the part and adds to reworks and scraps and stuff like that. So in total, from the purchasing of the blankets, the scraps and reworks, and the disposal cost of the blankets, it costs Ducommun $75,000 annually, and the blankets account for 3.6 tons of solid waste annually. So from examining the plant at Parsons, there was I found, in collaboration with another intern, there was a similar die to this one that used to be used in the vacuum press, but they found a separate way to do it where they would have the die and then the part and a metal like strap to retain the part and put pressure on it, and then it would be put into an oven and taken out and formed that way, which would eliminate the need for insulating blankets and reduce all the costs associated with that. So a similar die or a new die model was created by another intern, and that would cost it was found to cost $56,000, and from the net annual savings, the payback period was 0.7 years. Similarly, the hot presses use insulating blankets to insulate the sides of the hot press, and it has the same amount or the same downsides as the vacuum press blankets. So from calculating the purchasing cost, the rework cost, and disposal cost, they account for $114,000 annually and 2 tons of solid waste per year. An alternative that Ducommun found was implementing doors onto the sides of these hot presses. And this project was actually assigned to another intern, which worked on this throughout the summer. And they were able to make the design, but not quite. They didn't get far enough to estimate how much it would cost. However, it has the potential to save $159,000 because it would save the cost of blankets, reworks, and disposal, as well as it would likely insulate the press better. So it would result in like another $40,000 in energy costs, as well as a savings of 4,000 pounds of solid waste. The next project, it was Press 12. This is actually their SPF hot form, which whenever I first got there, it used cooling water by just taking it in from the city and returning it back to the wastewater treatment plant. And this accounted for about 61% of the plant's total water usage and $177,000 per year. Thankfully, during my time there, they installed a closed loop water system, which is how they cool their other presses as well. And this closed loop system was installed for $138,000. This brings also it requires energy to cool the water, so it reduced the annual savings to $161,000. But the environmental savings account for 11.2 million gallons of water per year and an increase of 180,000 kilowatt hours per year, with a payback period of 0.86 years. And my water jet chiller project, there were several configurations considered with this project because of how the water jets are located in the facility. There's one on one side of the facility and then 2 on the other side. So it would be difficult to have just one chiller for all 3 water jets. So for this presentation, I considered just having 2 chillers for 2 of the water jets and then 1 for the other. So like Press 12, it didn't, or the water jets currently just take in water from the city and then change it or send it back to the wastewater treatment plant. And it accounts for 530,000 gallons of water per year and $8,000 per year in water costs. So the alternative, like I said, was to install 2 chillers, one for one water jet and then 2 for the other 2 because they're close together. And the total cost of these chillers would be $20,000 and result in a net annual savings of $3,000 or $3,600 because of the costs to run the chillers. The environmental savings include 530,000 gallons of water per year and an increase of 53,000 kilowatt hours per year, and a payback period of 5.42 years. And since the payback period was so high, I decided to not recommend this project because they wanted to their range for payback period was a little under, they wanted something under 2 years at least. And my final project was abrasive recycling project. Ducommun uses two kinds of abrasives for their smoothing of their parts and cutting of their parts. They use aluminum. They use garnet for their water jets and aluminum oxide for their sandblasting. And these abrasives account for a total of 134,000 pounds of solid waste per year and $20,000 per year in disposal costs. So an alternative was to find a recycling plant to send it to. And there was one found, I believe it's in Texas, and they were able to take the abrasive at a much lower cost than the local waste company. And this resulted in a net annual savings of $18,000 per year and environmental savings of 134,000 pounds of solid waste per year. This is a summary of all of my projects and totals. So in total, they'd be saving $485,000 per year and 326 metric tons of CO2 equivalent per year. Thank you. Do you have any questions?
Okay, thank you.
Yeah, I guess that's just shocking to think about the running the water through those water jets just to cool. And I mean, you're not using the water for anything other than just a thermal carrier.
Yeah.
I guess one of the ways that I've seen companies kind of get away with using that amount of water, not necessarily for the purpose of the water, is to drill a well. And I guess has Ducommun given any thought to that, if they could possibly put in a well, if they're using that much water, because when you extract it, it comes out at 60 degrees. So it'd actually probably be a little bit maybe cooler than what you would get in the distribution system from the Parsons or from that industrial park. So I don't know, that's something that may be interesting to see in the future. But that's awesome that you got them to look at something different, because that's just a terrible use of water for cooling that you could easily chill it and use it again. So
Yeah, and it's I don't know if they're able to drill well, but there's another problem with using the city water is the pressure isn't always constant. It's more of a problem with press 12, but if the pressure decreases, then they won't be able to cool it fast enough. And they had several problems with press 12 because it would get up to like 1600 degrees Fahrenheit, and they wouldn't be able to cool the components inside of the part or inside of the press with like a low pressure from the city. So it would also like reduce like runtime and stuff like that.
Beginning of your slide, you talked about the Title V permit and Title II. It's not called Title II, it's Class 2, because then it would be a difference. That's usually that is for moving emissions, that those Title IIs are there. So this would be a Class 2 instead.
What was your favorite part of the internship?
I think learning about the hot presses and like the SPF press, because just like small holes in the blankets for the hot presses, from 10 feet away, you can feel the heat coming from the hole. And for the SPF presses, whenever it's open, you can feel the heat from like across the room, basically.
That's crazy. Anyone online? Do we have anything in the chat? Please give me cheesecake or something. Was there here? Did somebody found an old cake or
Oh, I remember that, yeah.
They turn off the fridge.
It was in a fridge. He was going through like old appliances and finding ones that weren't in use anymore. He didn't just find a cheesecake out of the plant. I just want to be clear on that.
Unused
I
refrigerator.
said, great job, Tyler.
Right.
Yay. Okay.
I guess, real quick, what are those blankets made out of? Because the only thing I could think of is asbestos. Would burn, and I sure hope that they're not asbestos blankets.
Yeah, solid waste. That would be
I think it's some kind of silicon.
Okay,
So it's like aluminum oxide something.
so it's like a spun rock wool kind of, but not,
Yeah, it's
not straight up asbestos or anything. Okay,
Yeah,
that's
it's, this is summer, it's a ceramic wool.
Ceramic wool.
okay, gotcha. All right.
Okay.
Clarify that one.
What makes you like him first?
There wasn't much there, so there was, yeah. There, in a town over about 40 minutes away in Pittsburgh, there's a place called The Pit. I went there a few times. They had half off wings every Wednesday, so I.
Oh, nice.
Tyler's very modest. He was our eating champion of all the interns that we've had. He took out a 24-piece wing and full fries.
Wow. You can see how red his little cheeks are.